Yeah. Yeah, good afternoon all. So before I start, can one please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yes, sir, it's visible and it's audible.
Thank you. Yes. So in this demo session, just I was briefing you about the Hadoop, right? So it is meant for both storage and processing, where you unlimited data storage and the processing, right? How exactly the data storage and processing is going to happen using Hadoop, right? And the Hadoop main advantages, right? Unlimited data storage, very high speed processing, can handle all varieties of data, structured, unstructured, and semi-structured, open source, commodity hardware. It can run on any hardware, right? Yes. And the speed of Hadoop, right? As compared with other databases, whether it has taken days of time, it has taken just minutes of time. To sort 100 TB of data based on 16 columns, so the time taken by Hadoop, it's just 1.2 minutes, whereas the other databases has taken. And here, if we talk, the databases has got some limit. So like Oracle, MySQL, DB2, SQL Server, there is a limit on the number of slaves, number of systems. They can go up to this max 256. In the case of specialized databases, they can go up to 1024. Beyond that, they cannot support, right? But there is no limit on the number of slaves that Hadoop can have. Yahoo, when first time implemented Hadoop, went with 4,000 slaves. Currently, it is going with 12,000. And Facebook, when first time implemented Hadoop, went with 8,000. Currently, it's going with 42,000 slaves, right? Yes. Yeah. So there is no limit on the slaves, right? So, so these are the Hadoop ecosystem components like HDFS for storage, MapReduce for processing, Hive also for processing. It's a data warehouse kind of environment. Scoop, SQL and Hadoop for import-export operation. NoSQL database I'll be discussing. Streaming technology like Flume, Kafka. Zookeeper for controlling and coordinate all the Hadoop components. And PySpark core programming, SQL, streaming, and PySpark ML lib, right? Fine. How exactly data stored and processed? How exactly data stored and processed? So generally in database, data is stored in the form of tables. Data is stored in the form of tables. Here in Hadoop, on Hadoop, data is stored. Data is stored in the form of files. In the form of files. In Hadoop, data is stored in the form of files. Each each file, each file is again subdivided. Each file is again subdivided. Subdivided into blocks. Default block size. Default block size means default block size. Talk about this Hadoop, right? The data storage. It follows master and slave architecture. Hadoop follows single master and multiple slaves. S1, S2, S3, so on, Sn. This is the master node. These are these slave nodes are data node. Master node or name node. data like got a file f1.txt file. Data is stored in the form of files. This file, huge data file, data object, right? It cannot be stored in a single file. It will be divided into smaller parts we call like blocks. The file is divided into smaller parts called blocks, and they are distributed across these slaves. We have nothing to do about this. Okay, it automatically, the master node, this name node, will divide the file into blocks and stores it across the multiple slaves. Default block size. What is the default block size? What is the size of each partition? Default block size is 128 MB. 128 MB. In previous versions, it was default block size was 64 MB. Default block size 64 MB. Even we can configure, even we can configure increase or decrease the default block size. Even we can increase or decrease the default block size. How much the default block size, how much each partition has to be. Even we can increase or decrease the default block size. So I'll discuss that, how we can increase or decrease. Assume it was previously 128 or 64. Even we can have our own block size. There is a file f1.txt. There is a file f1.txt file, right? Yes. Okay. Assume f1.txt file. Size f1.txt file. Size 200 MB. Default block size is assume 64 MB. Number into how many blocks? Number of blocks equal to default block size. Number of blocks equal to file size by default block size. Default block size 200 by 64 equal to 4 blocks. 4 blocks, right? 4 blocks means, right, B1, B2, B3, B4. B1 block, B2 block, B3 block, B4 block. B1 64 MB, B2 64 MB, B3 64 MB. 64, 64, 64, you got what? 192. And here only 8 MB. Remaining everything is free. 8 MB and remaining everything is free, right? Yes. So data, how data is divided into files? Data is divided into files. In data is stored in the form of files. The file is divided into fixed size blocks. Default each block size, like the previous version it was 64, now it's like 128 MB. Assume if it is 64, 64, 64, here 8 MB. f1.txt, assume the file is a banking file, banking data. You got some banking data in it. There is a file f2.txt. f2.txt is some telecom data. f2.txt, the size 192 MB exactly. Default block size is 64 MB. Into how many blocks this file is divided? Assume I taken a small size. Into how many blocks the file is divided means 192 by 64 equal to 3 blocks. 3 blocks, right? Observe, it's B5, it's B6 and B7. Sixty-four MB, 64 MB and 64 MB. That's fine. Here, why this B5 data is not stored in B4 even though like 56 MB free, right? 56 MB free. The query is why B5 data is not stored in B4. Why B5 data is not stored in B4? When 56 MB is free. Assume retrieving what? f1.txt. Retrieving f1.txt means b1 plus b2 plus b3 plus b4. b1 plus b2 plus b3 plus b4. If b5 data stored, assume if b5 data stored in b4. If b5 data stored in b4. So this is 64 plus 64 plus 64 plus 8 plus 56, totally 256 MB. You are trying to retrieve f1.txt, that is banking data, but actual file size is 200, but actual file size is 200 MB. But 56 MB extra you got, right? But actual file size is 200 MB, which is wrong computation. Which is wrong computation, right? Means extra 56 MB of telecom data you got in banking data. Whenever you are trying to retrieve banking data, you have got 56 MB of telecom data also in it, which is wrong computation. So every file will have its own blocks. Every file is going to have its own number of blocks. Yes. And if I talk about the design principles of this HDFS, right? Yes. Design principles, right? Yes. HDFS blocks. Design principles of HDFS blocks. Every block will have equal volume. Every block, design principles of HDFS. Design principles with respect to HDFS blocks. Every block will have equal volume. Except the last block. Every block will have equal volume except the last block. In a single block, no two files data to be stored, right? In a single block, no two files data to be stored. Every file will have data, every file. Dedicated number of blocks. Every file will have dedicated number of blocks. Right. I'm going to discuss 3 cases here, right? How this exactly that storage and processing is happening. I'll be discussing 3 cases here. Case 1. How this storage and processing, right? Case 1. If the number of blocks, so before that, configuring our custom block size, configuring our own custom block size. How can we? Yes, configuring our own custom block size. Configuring our own default block size. So go to Hadoop installed folder, go to Hadoop installed folder. Go to Hadoop installed folder, like within this Hadoop folder, within that conf folder. There'll be HDFS, there'll be a file HDFS-site.xml. Go to Hadoop installed folder, right? Go to Hadoop installed folder, Hadoop conf HDFS-site.xml. Open this HDFS-site.xml. Open this HDFS-site.xml. Open this HDFS-site.xml, right? And configure. Configure the following. So XML files, right? You'll have our own tags like configuration. So it will be an empty file. HDFS-site.xml will be an empty file. So if you want to configure your own block size, just write this configuration and /configuration. Property name, property name, distributed DFS, distributed file system dot blocks dot size, blocks dot size /name. Yeah, name and the value. What is the value, right? Yes. value is what? For example, I want 50 MB, 50 M I need to say, right? Yes, slash value. That's it. So here configuration, closing that configuration tag, property and closing that property tag, name and closing that name tag. What is that name? Property name dfs.block.size. What is the value? 50 MB. Configuring our own default block size, right? How much you want to set that means if you want to divide that file into, so this is the only thing we will be providing, or dividing of that file into blocks, everything taken care by this name node. But only thing is if you are giving this configuration, it will be divided into 50 MB blocks. Otherwise, by default, it will be 128 MB blocks. It automatically divides and stores across the multiple systems, slaves, we say, right? Now, I said how the storage and processing is happening. I'll be discussing 3 cases here and how the speed is going to be, right? Case 1. If the number of blocks, after dividing the file into blocks, the number of blocks, if it is equal to if number of blocks, if it is equal to number of slaves, how many blocks? Assume you got like 4 blocks, if equal to 4 slaves. 4 blocks means assume we got B1 block, B2, B3, and B4. Assume you got 4 slaves. System 1, system 2, slave 1, slave 2, slave 3, and slave 4. I got a file f1.txt. Assume the size of this file is 230 MB. Default block size, assume default block size 64 MB. Number of blocks equal to file size by default block size equal to 4 blocks. B1, B2, B3, and B4. Assume 10 lakh records in this, 10 lakh records in this, 10 lakh records in this, 10 assume. So these 4 blocks, how they are going to be stored across the cluster. This is the master. These are the slaves. 4 slaves, right? 4 systems. Master slave architecture, 4 slaves. Slave 1, slave system 2, system 3, system 4 slaves. Here B1 is stored, B2 is stored, B3 is stored, B4 is stored. B1, B2, B3. A file f1.txt. f1.txt. First it will go to this master node. Master node, within the master node, right? We have got name node, we say. Name node. The file, the name node will divide the file automatically into blocks. Who divides? Name node. Name node will divide that file into blocks and stores across these slaves, slave nodes, and we call the slave nodes data nodes. Slave nodes are data nodes. Who stores the data? Who stores these blocks? Slave nodes, data nodes. And what this master node or name node stores? Name node stores metadata. It stores what? Metadata. What do you mean by metadata? Data about data. Data about data. It won't store the data, but data about the data means if you got a file f1.txt divided into blocks B1, B2, B3, B4. Which blocks are stored in which slaves? B2 in S2, B3 in S3, B4 in S4. Entire information, everything will be available with the name node. which blocks are stored in which. Tomorrow, if you want to retrieve this file, which blocks are stored in which systems, everything, the information will be available in the name node. Now, data processing. Now understood, right? Data storage. Now, like data processing. 1 second. Yes. Now that is how exactly the data stored. Means a file f1.txt divided into blocks. The blocks are distributed across multiple slave systems, right? And are processed parallelly. Now, data processing. Data processing, right? Means your job is to process this f1.txt file. Always the job is divided into tasks. Into how many tasks? Number of tasks. In Hadoop, number of tasks always depends. In Hadoop, how many tasks or number of tasks depends on number of unique blocks. Number of unique blocks. How many blocks here? Totally 4 blocks here, right? Yes. So number of tasks also 4. Number of tasks also 4. Job to process f1.txt. Divided into 4 tasks. Here 4 tasks. T1 task, T2 task, T3 task, T4 task. T1 task for executing B1 block, B1 10 lakh records, right? For executing this T2 task. T2 task is for executing, right? B2 10 lakh records. T3 task is for executing. Is my voice clear to all? Can anyone please confirm once again? Yes. T4 task is for executing, right? Is my voice clear to all? Can anyone please confirm?
Yes, yes, it's clear, sir.
Yes. Okay. So how the job is divided into tasks? If the job is divided into tasks only, multiprocessing is going to happen. Yes, 4 tasks. T1 task for executing B1, T2 task is for executing B2 10 lakh records, T3 task for is executing B3 10 lakh records, B4 for executing B4 10 lakh. Who should execute this T1 task? S1, S2, S3, S4. Which one has to execute this T1? Everyone. Right to answer? Yes. I want the sessions to be interactive, right? Who should execute this T1? Means this B1 10 lakh records. Who can execute S1, S2, S3, S4? The B1 block, B1 10 lakh records is present in S1, right? Only this S1 only can execute this. The system or the slave S1 only can execute this T1 task, right? S1 only. For T2 10 lakh, T2 task for executing B2, who should execute it? B2 10 lakh records. That is T2 task is for executing B2 10 lakh records. Who has to execute it? S2. T3 by S3. T4 by S4. Means S1 only can execute this T1. S2 only can execute this T2 task, that is B2 10 lakh. S3 only can execute this. Observe. T1 task master node or this name node assigning T1 task to T1 task is to execute this B1 10 lakh records. T2 task is assigned to S2 slave 2 to execute B2 10 lakh records. T3 task is assigned to B3 10 lakh to execute this 10 lakh. And T4 task to execute 10 lakh records of this B4. Yes. So master node or this name node will assign the task to the slaves, slave nodes to execute that tasks. The tasks are nothing but executing these blocks. If 4 blocks, 4 tasks, right? So 4 tasks, right? 4 tasks T1, T2, T3, T4 are executed parallelly. Four tasks T1, T2, T3, T4 are executed parallelly by 4 slaves. Four tasks T1, T2, T3, T4 are executed parallelly by 4 slaves. S1, S2, S3, S4 parallelly. See, 4 tasks executed by 4 systems, 4 slaves parallelly, right? None of the task is in waiting state. All the tasks are executed parallelly. No task is in the waiting state. So here, full parallelism is here, right? Full high speed. We see like high speed, full parallelism. So whenever the number of blocks equal to the number of slaves, we see like full parallelism, right? We see like very high speed. Yes, this is case one. So how this file f1.txt divided into blocks, fixed size blocks of 64 MB. So how they are going to be distributed across the slaves, what the master node stores the metadata information. This data node stores the blocks of information, and data processing always the job divided into tasks. How many tasks means depends on blocks. 4 blocks, so 4 tasks. 4 tasks for executing 4 blocks. These 4 tasks executed by 4 slaves and are executed parallelly. Observe this case 2, right? No, observe this case 2. In case 2, assume the number of blocks are greater than number of slaves. Number of blocks greater than number of slaves. How many blocks? 4 blocks. How many slaves? 2. Think you have got 4 blocks. B1, B2, B3, B4. How many slaves? 2 slaves. S1, S2. Once again, check this f1.txt. Assume the size is like 230 MB. Assume the default block size. 64 MB into how many blocks? See, if number of blocks greater than number of slaves, less speed. Default block size equal to 64 MB into how many blocks? 230 by 64 equal to 4 blocks. So how many blocks? 4 blocks. B1, 4 blocks. B1, B2, B3, B4. Think in each block some lakhs of records are stored. 10 lakh, 10 lakh, assume. Yes. These blocks are master, and these are the only 2 slaves. You got only 2 slaves. You got only 2 slaves. S1, S2. 2 slaves, right? This master or name node. Master node. Within the master node, we see like a name node available. Name node which stores metadata, data about data, right? So here, B1 block stored here, B2 stored here, B3 stored here, B4 stored. These 4 blocks stored across the two systems. Here f1.txt divided into 4 blocks, b1, b2, b3 and b4. b1 stored in s1, b2 stored in s2, b3 in s1, b4 in s2. This blocks and which block stored in which slaves, that information will be available with the name node. Entire metadata information will be available, right? How this file divided into blocks and how this block stored across the systems. Now, if you talk about this data processing, right? Job to process this f1.txt. Always the job will be divided into tasks. In Hadoop, always the number of tasks depends on number of unique blocks. I'll say why the word unique. Number of unique blocks are how many? 4 blocks. 4 blocks means 4 tasks. Okay, observe this job to process f1.txt into 4 tasks. T1 task, T2 task, T3 task, T4 task. One second. Okay. T1 task is for executing. T1 task is for executing B1, right? 10 lakh records. T2 task is for executing B2. T3 task for executing B3. 10 lakh records. T4 task is for executing B4. Who should execute this T1 task? Yes. Who has to, which system has to execute which slave? T1 task for executing B1. S1 only, right? T2 task for executing B2. S2. Again for B3 block. This T3 task for executing B3. S1 only. B4 block. B4 block is for executing T4. That is T4 task is for executing B4. Who has to execute that? S2. S1, S2, S1, S2. Means here, if you got, assume you got S1 is there. Assume here you got slave 1 is there, slave 2. Slave 1 executing 2 tasks T1 and T3. S2 also executing T2 and T4. Here when T1 task is executing here in S1, here T2 task will be executing. So in S1, if T1 is executing, T3 task will be in the waiting state, right? In the waiting state. When T4 task, T2 is executed, T4 will be in the waiting state. Means once this T1, T2 execution finished, then only T3, T4 task will be executed. Means here some tasks are in the waiting state, right? So here you see less speed. In the first case, 4 tasks executed by 4 systems. Each task taking 1 hour. Total time taken for to execute all the 4 tasks parallelly, 1 hour. But here, if each task takes 1 hour, first T1, T2 will be executed, 1 hour completed. Next T3, T4 to execute also 1 hour. So 2 hours it takes. Less speed here, right? So some tasks are in the waiting state because the slaves are less, but the blocks are more. So the tasks are more. So here T1, T3 task one after the other executed by S1. Here T2 and T4 task one after the other executed by. So there is no full parallelism here, right? All the 4 tasks are not executed parallelly. Yes. Now observe this case 3. In case 3, more blocks, only one slave. Think you got 3 blocks, only one slave. B1, B2, think there are 4 blocks, only one slave S1. F1.txt, 230 MB, yes. Default block size 64 MB. Into how many blocks it is divided? 230 by 64. Two 30 by 64. Two 30 by 64 means how many blocks? 4 blocks. B1, B2, B3, B4. How these 4 blocks are stored across the only single system, right? Single system. S1. This master node. Within that, we got a name node. Name node stores the metadata. F1.txt divided into 4 blocks. Here, B1 stored here, B2 stored here, B3 and B4. All the blocks stored in the one system. T1 task into 4 blocks, B1, B2, B3 and B4. B1 in S1, B2 also in S1, B3 also in S1, B4 also in S1. All the blocks are stored in the single slave. Data processing. Job to process F1.txt. Number of tasks. Number of unique blocks. Number of tasks equal to number of unique blocks. How many? 4 tasks. Job to process F1.txt. 4 tasks. T1, T2 task, T3 task, T4 task. For executing B1, T2 task for executing B2, T3 task for executing B3, T4 is for executing B4. T1 task executed by S1 only, T2 also by S1, T3 also by S1, T4 also S1. 4 tasks T1, T2, T3, T4 are executed by single slave. 4 tasks are executed by single slave S1 sequentially. 4 tasks are executed by a single slave sequentially. Okay, here no parallel processing at all. Here no parallel processing. All that four tasks will be executed one after the other. It's like if each task takes 1 hour, so for four tasks it takes 4 hours. Right? In the case one, it takes 1 hour. In case two, it takes 2 hours. In case three, it takes 4 hours. Right? If more slaves, more speed. If less slaves, less speed. If only one slave, right? No parallel processing. So if I go back to this case one, observe this case one, right? Four tasks are executed by the four slaves parallelly. Four tasks are executed by the four slaves parallelly. If any one system or slave, right, if goes down, then you observe two things you observe, right? This 10 lakh records are lost. Secondly, this T2 task is failed. T2 task is failed means the job also failed. If all the four tasks are executed successfully, then only the job is executed successful. So here the task is failed, the B2, that 10 lakh records are lost means there is a data loss and the task job failed. How Hadoop is going to overcome this kind of situation, right? Means if 10 lakh records are lost, if the data is too sensitive data, like banking data or banks, 10 lakh records are lost means huge loss, right? And if job is failed, there is a concept called replication and fault tolerance. There is a concept called replication and fault tolerance. Replication and fault tolerance. It has a powerful fault tolerance model. Replication means what? Duplication. What you are going to duplicate? Duplication. Default number of duplications. Default number of replicas. In Hadoop, by default, you can have three duplications, three replications, right? We can also configure. We can also configure. We can also configure, right? Increase or decrease. Increase or decrease, right? Yes. We can also configure increase or decrease the replications. But by default, it is three. See, these replications or duplications, these three times duplications or replications can be applied to whom? Default number of replications, this three, is it applied to a file or blocks? Understand what is this replication and fault tolerance? Observe, right? Replication and fault tolerance. Okay, I got a file f1.txt, 192 MB. Default block size assume 64 MB. Into how many blocks it is divided? 192 by 64. Three blocks. Three blocks means like B1, B2, and B3. B1, B2, and B3. Three times replication. B1 replicated by 3, B2 replicated by 3, B3 replicated by 3. Totally 9 blocks. Totally 9 blocks, right? Yes, how these 9 blocks are going to be distributed across this cluster. Single master, multiple slaves. Assume you got 3 slaves. Slave 1, slave 2, slave 3. This is master node. In that we have got like name node. Name node stores the metadata f1.txt has got a 3 divided into 3 blocks b1, b2 and b3. b1 stored, okay, how these 9 blocks stored across these 3 slaves means b1 here, b2 here, b3 here. Again b1, b3, sorry, b2, b3. Again here b3, b1, b2. So total 9 blocks stored across these 3 slaves. So b1 stored in s1, s2 and s3. b2 also stored in 3 slaves. b3 also stored in 3 slaves. Now data processing. Data processing, right? Job to process this f1.txt into number of tasks. In Hadoop, number of tasks depends on number of. Now you see that unique. Why I have taken this unique blocks? Number of unique blocks. Is it 9 or 3? Is it 9 or unique blocks are what? 3. 3 tasks. Here 9 are duplicated ones. Unique. Number of tasks equal to number of unique blocks. How many tasks? 3 tasks. Job to process this f1.txt, yes, into 3 tasks. T1 task, T2 task, T3. T1 is for executing B1. T2 is for executing B2. T3 is for executing. Now, who should execute this T1 task? That is B1. B1 is present in S1, S2, and S3. Should I say only S1 can execute this T1 task? Previously, B1 was present in S1, so S1 only can execute. But here, T1 is B1 block is present in S1, S2, and S3. So S1 can execute, S2 can execute, S3 can execute this T1 task. Assume to execute to T1, master node has selected S1 only. And T2 also can be executed by S1, S2, and S3. So to execute to T2 task, slave 2, and to execute to T3 task, T3 task, right? Master node has selected S3. Okay. Who should execute T1? S1. Who should execute T2 task? Who should execute T3 task? S3. T1, T2, T3. The 3 tasks are executed by the 3 slaves. 3 tasks are executed by the 3 slaves. Assume when 3 tasks are executed by the 3 slaves, suddenly this S2 is down. Do you see, is there any data loss? If B1, B2, B3, still that B1, B2, B3 are available in the other slaves, there is no data loss. When 3 tasks executing parallelly by the 3 systems, 3 slaves, if any system goes down, still the data available, right? And this T2 task will be assigned to any of the other slave, to S1 or S3. Here I got one query. Why this T1 task is assigned to S1, why not to S2 or S3? What is the criteria followed? So internally, all this is going to happen, which you cannot see, right? Like T1 task assigned to S1. Why the priority is given to S1? Why not to S2 or I3? What is the criteria followed in assigning a task to a particular slave? What criteria is followed? That is one. Second one is, if any system fails, the T2 task to be assigned to which slave? S1 or S3? To which one the priority is given? What is the criteria followed, right? Yes. So here, S1, slave 1 executing T1 task. S2 executing T2 task. S3 executing T3 task. If this particular system is down, then T2 task assigned to S1 or S3. Which one? What is the criteria? And that is one. And also, like, what is the criteria followed? What is the criteria followed in assigning a task to a slave? 4 steps criteria. What is that? 4 steps criteria. 4 steps criteria, right? Four steps criteria. First one. So to which one? S1 or S3 means master node selects the slave. Master node selects the slave which is highly configured, means which has high hardware configuration. Assume if both the slaves, right? If both the slaves has got the same configuration, then if both the slaves have got the same configuration, then to which slave the task has to be assigned means master node selects the slave which is more ideal, more ideal means which is more free, if both the slaves are free, master node selects the slave. The master node selects the slave which is nearest to it. Master node selects the slave which is nearest to it. Means a master can be in one state, one city, slaves can be in different cities. See, master can be in one country, slaves can be in different countries. Master in one state, slaves in different state. Master in one city, slaves in different cities. Otherwise, all master and slave can be within the same lab. Assume even if If both the slaves are equally near, if both the slaves are equally near, right? Then master node selects master node, yes, selects the slave which has good health status, which has good health status, which has got good health status. Means even though they have got high configured, but the health status, think that one slave is see the hardware and software configuration now and then a particular slave is going down. So which has got good health status. If both has got if both has got good health status, if both has got the good health status, in the extreme case, in the extreme case, it selects any one slave randomly, any one slave randomly. The extreme case, it selects any one slave randomly. But generally, right, in the first or second case, it will be assigned. So what is the criteria followed? I said, right, if to assign a particular T1 task to S1 or S2 or S3. So this is the 4 steps criteria followed. Yes. What do you mean by fault tolerance? Based on this discussion, fault tolerance. If three tasks, assume T1, T2, and T3. If three tasks T1, T2, T3 are executed parallelly, if three tasks are executed parallelly by three slaves S1, S2, S3. If three tasks are executed parallelly by three slaves S1, S2, S3. Suddenly, if any one slave, assume S2 goes down, then the task, what is the task? T2. Then the task will be assigned to the available slaves. To the available slaves. This process is called as fault tolerance. This process is called as fault tolerance model. Yes. This process is called as fault tolerance. And design principles with respect to replication. First one, replication applicable. Replications applicable only for data, but not for metadata. Replications Replications are applied only within the slave nodes, not in master node. Same replicas cannot be within the same slave. Same replicas cannot be within the same slave. Same replicas cannot be within the same slave means, for example, yes, if you got this is the master, these are the slaves. 2, 3. 3 times replication applied. So here S1, S2, S3. So here B1, 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 B2, 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 B3, B3, B3. This kind of things. If suddenly slave 2 is down, is there any data loss or not? If B2, B2, B2 stored in S2, suddenly if S2 is down, is there any data loss? B2 data is lost, it's not available in S1 or S3, right? So the 3 blocks should be distributed across 3 slaves. All the same replicas cannot be within the same slave. Okay. Max number of replications. Max number of replications. Max number of replications equal to number of slave nodes. Number of slave nodes. If you have got 30 slaves, 30 times replications applicable. Number of slave nodes. Max number of replications equal to number of slave nodes. Okay, fine. I also said, right, we can increase or decrease the replication. So already we have discussed about this block size, right? Configuring block size and replication. Once again, configuring default block size and replication. Default block size and replication, right? Go to Hadoop folder, same thing. Here once again you copy paste this property. One more property I want to set. By default replications as what? 3. DFS dot replications. How many? By default is, if the data is more sensitive, keep 4 or 5 or 6. We want, if it is not sensitive, it is insensitive, it's not a sensitive data like Facebook data, social media data, right? You can decrease the replications here. 4 or 5, or you can increase this replications, right? Yes. Configuring block size and replications, design principles with respect to replications, what is fault tolerance, what is replications, and 4 steps criteria, what it is followed, and how penny slave goes down and how it is rectified, right? There is no data loss, there is no task failure, and 3 steps. I discussed the 3 cases, how exactly the data storage and processing is going to happen, right? Yes. Configuring our own block size and design principles with respect to HDFS blocks. Design principles with respect to HDFS blocks, right? Yes. So default block size, we can keep our own block size, which is advantageous. Which is advantageous? Which is advantageous? Having a bigger block size, having bigger block size, or smaller. If you keep big default block size as 250 MB or 300 MB or 500 MB, or keeping a smaller block size. Okay. Assume I got f1.txt. f1.txt. Thousand MB. Assume this file size is 1000 MB. Default block size as configured as default block size. Yes, assume this default block size equal to 500 MB. Number of blocks. Number of blocks equal to number of blocks. 1000 by 500 equal to 2 blocks. 2 blocks. B1, B2. Is it advantageous? B1 stored in system 1, slave 1, B2 in slave 2. Means here, if you are keeping the default block size as 500, it's a drawback, right? Here only two systems are running. Here only two slaves are running parallelly. Are running parallelly. Here only two slaves are running parallelly when you got many. When we got many slaves. When we got many slaves available. It's nothing but when if you brought a labor, if I give a labor example, if you brought some labors like 20 labors you brought for a building construction, but you brought 20 labors, but you have given task to only two slaves, two labors only you are given, but remaining 18 are ideal, right? If you have given the task, if you have divided the task into 20 tasks, and if you have given to 20 labors, they should have completed the task very faster. Here also, only two blocks, two systems are running parallel. Instead, if you have kept the block size very small and if you have distributed the task to multiple systems, you will get more speed, right? Even though you got more slaves, still the speed is less here because of default block size kept as 500 MB. Observe this example too, right? Here, okay, f2.txt, just 60 MB, 70 MB. Default block size 10 MB. I kept very small block size. 70 by 10. 70 by 10 equal to 7 blocks. Equal to 7 blocks, right? Means here, is it advantageous? Means 7 systems running parallelly. Is it advantageous, right? 7 systems running parallelly for 7 blocks. Here, already a very small file. Here already a very small file. And again, dividing into multiple partitions. multiple partitions. Again, dividing into multiple partitions and storing across multiple slaves. And processing and retrieving. And processing and retrieving, which is a time-taking process, So the default block size. So Hadoop has given Hadoop has given default block size as 128 MB, which is not too big, not too small. Understood, right, everyone? So we cannot have the block size as too big or too small. So depending upon, you can configure this block size and replications, right? So yes, in the next class, I'll be discussing about this storage architecture and processing architecture. You have got some components, right? I'll be discussing and I'll be briefing you about the software, and that will be going with the practical part. So next we converse that there will be a practical part. A small discussion is left out like storage and processing architecture, the components, and I'll just demonstrate about the software. It will be forwarded. See, software will be forwarded to your Google Drives. So if you got enrolled, you can check your Google Drive. The software will be forwarded to that, like nearly 5 GB. It will be, everything will be clear. All the Hadoop components, even Spark with PySpark, Spark, everything will be available in that for practice purpose. And videos, if you got enrolled, you can check the videos in your Google Drive. In that Google Drive, shared with me option will be there, right? Google Drive shared with me option will be there. In that you can see the videos. So software you will be getting to Google Drive. Videos you will be getting to your Google Drive. Shared with me option. Every video you will be getting. Notes you will be getting to your mail. In the okay, today or tomorrow you can see, right? That's whatever notes clear. Not only this, the all the cases, everything, what all we discussed yesterday, today, right? Everything in the neat manner. This notes will be forwarded, right? Yes. So in the coming sessions also clear notes for every topic. So the sessions I want more interactive, right? The sessions in the coming practicals, right? I want the sessions to be more for every statement I type, you will be responding, right? And I said software to Google Drive, videos to your Google Drive, notes to your mail IDs. Yes. Next Saturday, a WhatsApp group will be created from the enrolled students, right? Whoever got enrolled, that a WhatsApp group will be created by next Saturday. Fine. And I said I'll be discussing on different environments how to execute this. Step by step, everything will be neat and clear. You will understand 100%, right? Whatever it is, whether you're from zero background, that is programming background, right? So I said if you want the fee structure, right? Hadoop, PySpark, and Linux. With Python, it will be like 15,000. Without Python, it will be like 12,000, right? So Python, it will be like nearly 2 months course will be there. Uh, Morning the 6 a.m. batches are available, 8 p.m. batches are available. Check it with that. You can see that contact details of this online team, this office team, right? You can check in the chart panel. A big message is given. So you can copy that message, right? For that payment process. And you can see the videos, means demo videos and this big data analytics course content. Yes, yes. So whenever we go with the practical part, I'll be just extending the session, right? Yes. Any queries from your side, anyone? Right.
Do we do any projects, sir?
At the last, I'll be showing you one flow, right? Flow,
Okay.
one flow I will be. Yes, so get enrolled, right? So
Hello, sir.
next week, 1 second. Next week, next Saturday, you'll be getting a new link, right? You are going to get a new link. Check your mails, right? And if you are still paid, but still you are not received the link, you can just contact this mobile numbers, right? Two mobile numbers are provided. Yes, can you see the two mobile numbers? Yes, contact details are given. And once, if some of you, right, they'll be facing problem, even though they have paid, still they didn't get the link because, see, whenever you pay the fees, you need to send the screenshot of your payment to this mail ID, durgasoftonlinetraining@gmail.com. So they will forward that link to the same mail ID to which you have forwarded the screenshot. And to the same mail ID, they will be uploading the videos, right? So try to send the screenshot of your payment to this, and also just mention that for which course and the timings in that, right? Fine. The payment details in this, all this is provided here in this chart, right? In the message, the Google Pay or this any other. So still, if any other, you can just contact that details in the office team. Fine. Now go with your queries, right? Yes. So this is live sessions, right? And it's not like you need to ask the queries at the end of the session. No. During the session, immediately you can ask the session, either through voice you can ask, or you can type in the chat panel. I'll be just looking into it and I'll be answering it, right? So everything you'll be understanding clearly. Just so when Saturday and Sunday, you'll be getting time to practice during the week. You'll come out with that practical exposure. That next sessions will be very simple and easier. So you'll be getting all the videos, right? Hadoop, PySpark, Python videos, all this, right? Fine. Yeah. Now go. Someone, yeah, someone was asking a query. Yes.
Sir, yesterday I asked about only Hadoop, right?
Yes.
So it covers up to Zookeeper.
Yes. Everything will be discussed.
Okay.
Hadoop complex.
Yeah.
Everything, whatever I said, everything will be covered.
So only for this Hadoop related things. So how many weekends will it take? Yeah.
So it's a Hadoop and PySpark, right? It's totally 15 weekends. It is said Hadoop I'll be covering for 7 weekends, 6 to 7. PySpark.
Okay, sir.
Okay, fine.
Okay.
Sir.
Yes. Yes, go ahead.
Sir, I had did Hadoop full 10,000% Python full under you. So now I'm looking for the PySpark. So do I need to pay the full amount or any other partial payment is the need to pay?
No. Only partial payment. You need to already, if you're done Hadoop and Python, right? You need to pay partial payment only.
Yes,
only for PySpark will be paying for it. No, not the total amount. So I said, yesterday I was saying, right? Total package if you want to take, okay. Otherwise, only one component you want.
Hello.
Yes.
Hello.
So that one component price, sorry, your voice was breaking. I was not able to hear you. So that one component price, how to know, sir?
You want only PySpark, right?
Yes, sir.
You want only PySpark you're talking, right? Yes.
Yes, sir.
The contact details are given, right, in the chat panel of this office team.
Oh, okay.
You can just call them. They'll just intimate.
Okay.
Yes.
Okay, sir.
Okay, fine.
Thank you, sir.
Okay. Yeah. Any other, right? Any other queries? Yes. So, okay, next week we'll just go with the same timing, right? 2:30 to see more on this, right? Fine. Check, get enrolled and get the link and this video software notes, right? Yes, Manoj. So the Manoj, right? Yes, I'll be discussing one flow, right, at the end of this. Okay, fine. So I'm stopping here. Yes, thank you for your time. Yes, meet you next Saturday, right? Yes. Fine.
Sir, hello.
Yes, go ahead.
Sir, are we going to see the installation part next week?
Yeah, I'll show you that. Yeah, and everything, the software, everything I'll be discussing.
Okay, sir. Okay.
Okay, fine.